This is the most important device in modern history. It's called a NAND Gate. You've probably never seen it before, but it's the reason you're watching this video. It's the reason your computer, your phone, and even the entire internet work. At its core, a computer is just billions of these tiny switches flipping on and off. How can something this simple run something this complex as a video game or even artificial intelligence? Let me show you. Before we can understand NAND gates, we need to talk about logic gates in general. A logic gate is a device that takes in one or more binary inputs, 1 or 0, and gives an output in 1 or 0 by following a rule. It's like a rule-following switch. You feed it a set of 1s and 0s, and it spits out a 1 or 0, sometimes called true or false. Think of it as a vending machine that only works if you insert 2 specific coins. There are different kinds of vending machines, just like there are different kinds of logic gates. The AND gate only gives a 1 if both inputs are 1. The OR gate gives a 1 if either one is. There's also a unique kind of logic gate, called NOT. It will always put out the opposite of whatever you put in. There are others too, but we don't need them today. When you combine the NOT gate and the AND gate, you get NAND. NAND puts out 1 if both inputs are 1. All these rules might start to get a little confusing, but thankfully, we can use truth tables to see what output you get for which inputs, like multiplication tables. NAND gates are unique. They have the ability to make all other logic gates by using a combination of just NAND. It's called functional completeness, and it's like building all Lego sets using only 1x1 Lego pieces. Don't do that, by the way, it's not very fun. Now you might be wondering, but how exactly do NAND gates build everything else? It sounds weird at first, but it's actually pretty simple. If you take a single NAND gate and connect a signal to both of its inputs, it behaves like a NOT gate, flipping what you give it. If you want to make an AND gate from NAND gates, hook up 2 inputs to one NAND gate, then take the output of that NAND gate and connect it to both inputs of another NAND gate. The output of the second NAND gate will now match the AND gate. If you want to make an OR gate from NAND gates, you can take 2 of the NOT gates we made from NAND gates, attach the inputs of both to different signals, and attach the outputs of each to another NAND gate's inputs. This way, the third NAND gate's output will match the OR gate. You should now be able to see why the NAND gate is so powerful. Instead of having to manufacture different kinds of logic gates, you can just make a load of NAND gates, and with enough NAND gates, you can build an entire computer. People have done that before, by the way. There's an entire project dedicated to teaching you how. It's called NAND Tetris, and it was actually the inspiration for this video. A big thank you to Noam Neeson and Simon Shokin, the creators of NAND Tetris, for making this video possible. I'll link NAND Tetris in the description if you want to try building your own computer from scratch. But where did this all start? Who invented the NAND gate? All the way back in 1854, George Boole published his An Investigation of Laws and Thought, on which are founded the mathematical theories of logic and probabilities. God, that is a mouthful. In this book, he showcased boolean logic, a system for math based entirely on true and false. Fast forward to 1937, when Claude Shannon, a graduate student at MIT, wrote his thesis explaining they can use switches to do logic. Claude Shannon also helped to found artificial intelligence, so he's a pretty big brainiac. However, it wasn't until 1950 that logic fully entered machines with the transistor, an electrical device with the ability to increase a signal, placing the outdated vacuum tubes. Vacuum tubes were used during World War II in the earliest computers. One computer called the ENIAC would take up an entire room. Nowadays, the computer can fit into your hands. Isn't that crazy? Thankfully, this is no longer the case, as computers' ability to remember has increased a ton. But wait, how exactly does a NAND gate remember? It's not alive, right? It seems wild, but a NAND gate can remember by using feedback, where part of the output loops back into the input. This makes the circuit enter a locked-in state that doesn't change unless it's told to. This is called a latch, and it's a simple memory circuit made from 2 NAND gates. It can store 1 bit of information, either a 1 or a 0. When you trigger the set input, it stores a 1. When you trigger the reset, it stores a 0. Until you tell it otherwise, it remembers that bit. The crazy thing about this is that these tiny loops of logic are the foundation for how your computer stores memory. Isn't that random? Speaking of random, the RAM, random access memory, in your computer does the exact same thing, just on a larger scale. At a basic level, RAM is made up of millions of tiny memory cells, each storing a single bit, a 1 or a 0. Inside each of these memory cells lies a circuit based on logic gates. It's more complex in practice, but this single feedback loop is where it all starts. So, what's the difference between a normal switch and a latch? The main difference between the two is that a normal switch turns things on or off, but a latch can hold value even after you stop pressing the button. A light switch flips the light on, but a latch remembers whether the room should stay lit. That's what makes it so important. You can now build memory, the foundation of data. But why do we need memory? The reason for this is because without memory, computers will forget everything the moment they calculate it. Every number, every button you press, and every meme you download needs to be stored somewhere while the processor works on it. Memory lets computers keep track of what they're doing. And with billions of these bits of memory working together, you're closer to an actual processor. But that raises the next big question. How do all these tiny pieces of logic and memory work together to compute things? Logic gates don't just sit around on the couch all day like our lazy uncle. They can be arranged into circuits that think. Adding numbers, comparing values, and even asking ChatGPT questions that could have been answered with Google. For example, by wiring logic gates in a specific pattern, you can build an adder, a circuit that takes two binary numbers and outputs their sum. But that's just the beginning. You can also build multiplexers for selecting data, comparatives for checking value, and counters to keep track of time or operations. When you put all these circuits together along with bits of memory and control logic, you get the most important part of your computer, the CPU, which means Central Processing Unit. It's the brain of your computer, run by billions of NAND gates, all working in sync to run programs, solve problems, and process information billions of times a second. So, next time you're scrolling your phone, playing a game, or watching this video, remember, underneath all of it is a tiny switch, a NAND gate, billions of them. But here's the twist. These logic gates don't just follow logic, they are logic. And in the next video, I'll show you how to use math you've never seen before, where 1 + 1 = 1. We're going to dive into boolean algebra, the strange and powerful language behind everything your computer does.